This is lesson 8.1, sine, cosine, and tangent for right triangles, part 1. This will be split into 2 parts. This is the first lesson of chapter 8, trigonometry. Our first question is, what is trigonometry? It's the angles and measurements of triangles. And where is it used? All over the place in the real world. Some examples would be navigation, astronomy, business, engineering, physical sciences, social sciences, etc. So it's all about triangles and the angles and measurements of triangles. This is a vast subject, and this is just a brief introduction to it. So this year, you're just going to learn about the angles and measures of right triangles because they're a little simpler. Some vocabulary. A right triangle is a triangle with a right angle. Remember, a right angle is 90 degrees. So right here is an example of a right triangle. Hypotenuse, you may have heard of this word before, but a hypotenuse is the longest side of a triangle, and it's always directly across from the 90-degree angle. So our hypotenuse is right here because it's directly across from the 90-degree angle. Theta, this is a Greek symbol used to represent an unknown angle. So it's pronounced theta, and it's kind of like this oval with a line through it in the middle. This represents an unknown angle. So you'll see this a lot when we're working with trig. So I just put my theta here to represent this unknown angle, but maybe you could have also called this theta because we also don't know that angle. So we had to get used to using this vocabulary, especially hypotenuse and theta. So you might be wondering, if the longest side and the one opposite 90 degrees is called the hypotenuse, do the other side lengths have a name as well? And no, they don't specifically have a vocabulary word for those side lengths, but we can either call them the opposite side or the adjacent side, depending where they are in relation to theta. So if theta is right here, then this side would be considered the opposite side because it's the side length across from theta or opposite from theta. So that's kind of what I was showing here. Theta is in this corner, so this would be called the opposite side. Adjacent, that word means beside. So the side length that is beside theta is called the adjacent side. Now, of course, if you look at theta, there are 2 side lengths that are beside it, but one of them is already called the hypotenuse, so it is whatever side length is not the hypotenuse, which again, you can always easily identify because it's directly across from the 90-degree angle. So quick recap, the longest side length is hypotenuse. Wherever theta is, whether it's here or here, you can label the other ones opposite side or adjacent side based on where they are in relation to theta. So now we're going to talk about the fundamental ratios of trigonometry. Because right triangles share similar proportions, we can calculate angles and sides of right triangles using these special trig ratios called sine, cosine, and tangent, which I have here. So these 3 words are ratios of 2 sides of a right triangle. We'll start with sine, S-I-N-E, it's pronounced sine, and you'll see it on your calculator as sin, S-I-N. So the ratio that you need to memorize is that sine theta equals opposite over hypotenuse. What that means is in a right triangle, if theta is here, let's say, this is a hypotenuse, this is the opposite side, and this is the adjacent side. So sine of theta is going to be this side length divided by this side length. So it represents a ratio between different sides on the triangle. Cosine is pronounced, well, I just said it, cosine, and it's on your calculator as cos. So you might just hear it as cos. And this ratio is here. Cos theta is adjacent over hypotenuse. So again, we have our triangle. If this is theta, this is the hypotenuse, that's opposite from it, and this is adjacent. So the ratio cos theta would be this side length divided by this side length. So it doesn't matter what theta is. If you calculate cos of that angle, it's going to be this first side length over this side length. And then tangent, this is on your calculator as tan. That ratio is tan of theta is opposite over adjacent. So this is the only one that doesn't talk about the hypotenuse. So it would be opposite divided by adjacent. That would be that ratio. So it kind of includes all possibilities, like each side length is with the other one. And it represents how those side lengths like the measures of them in comparison to each other. You can remember these ratios using the acronym SOH CAH TOA. Kind of tried to write the pronunciation of SOH CAH TOA, and this will help you remember because SO means sine has opposite over hypotenuse. So SOH is sine has opposite divided by hypotenuse. And CAH means cos, the cos ratio is adjacent divided by hypotenuse. And TOA is the tan ratio is opposite divided by adjacent. So if you remember SOH CAH TOA, then you can remember all of these ratios. So how do we use these trig ratios on your calculator? You need a scientific calculator with the sine, cos, and tan buttons. So maybe take a second now to look at your calculator and see if you can find those buttons. If you have a pretty simple calculator, like a non-scientific one, you might not have these buttons, but you can find online versions of them. So right here is a link to an online scientific calculator that has those buttons. Also, sometimes your phone calculator might have it, and you may have to rotate your screen in order for more of the buttons to come up. So this is a screenshot from the online scientific calculator. You can see that you have the sine, cos, and tan buttons, and then these other ones here that I'll talk about shortly. Another important part when you're using your calculator with trig ratios is you have to make sure your calculator is in degree mode. So you see here there's DEG or RAD. We don't have to really worry right now about what the rad or the radian mode is, but we don't want radian mode. It has to be in degree mode in order for things to calculate correctly, because we're working with degrees as opposed to another way to represent angles. So your calculator is probably in degree mode already, but if you turn it on, you might see at the bottom right, a couple letters, DEG, that means you're in the right spot. And if you're having trouble converting from back or getting it back to degree mode, you can simply Google it for your specific calculator, or you can ask me. So we'll practice using our calculator to calculate some trig ratios and then ask yourself, like, what does this actually mean? What are we looking at? So first example, use a calculator to write each ratio in decimal form, round to 4 decimal places. So the first one we want to find there is sine 65. So in this case, the theta, or the angle, is 65 degrees. So if we had this right triangle, let's say I'll make that a little bigger. We had a right triangle, and one of our angles is 65 degrees. We don't know the other angle, and we don't know the side lengths, but that's okay. The sine ratio is the opposite side divided by the hypotenuse side. So what we're calculating when we use our calculator for this is that the ratio of the opposite side length divided by the hypotenuse is going to give us, in this case, 0.9063. So we're calculating what that ratio is. Even though we don't know the side lengths, we know what one divided by the other is because we know what theta is and because we know this is a right angle triangle. So to calculate sine 65, you just type sine and then a bracket might come up. You'll type the angle 65, make sure you close the bracket, and then you'll get this value that you can round to 4 decimal places, 0.9063. And we can calculate the other trig ratios as well. So cos 65 and tan 65. And you do this the same way. Just click your cos button, type in 65, and press equals, and you can round it. So you'll notice that each of these ratios are slightly different, even though this would be going from the same triangle, the same right triangle with a 65-degree angle. They're different numbers because we're looking at different ratios. Sine, cos, and tan compare different side lengths of the triangle. Another note to remember, your calculator has to be in degree mode. If you're not getting these values, then it might be in a different mode, and that's where you need to fix it. So I kind of just talked about this, but what do these values mean? What are we actually looking at? They represent ratios of 2 sides of a right triangle. So in this case, the theta is 65, and we're looking at the comparison of how these side lengths relate to each other. What are the ratios of these side lengths? So I listed out all 3 trig ratios, and remember we have to memorize this: opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, which we can remember using our SOH CAH TOA. So again, this is telling us that from this, in this triangle with a 65-degree angle, if we divide the opposite side length by the hypotenuse, we'll get this value. If we divide the adjacent side length by the hypotenuse, we will get this value. And if we divide the opposite side length by the adjacent side length, we'll get this value. We can also use trig ratios to solve for angles. So we were just solving for how the side lengths compare to each other. We can also solve for these specific angles, or theta. We're going to do this by isolating for theta by bringing the trig ratio to the other side of the equation. When you do that, it changes the ratio from a normal trig ratio to an inverse ratio. So it's going to look like this on your calculator. So there's another button with the trig inverse functions. They're the exact same thing, except it has this -1 exponent. So if you're looking for it on your calculator, most of the time, it's actually the same button as your sine, cos, and tan, but you have to click second function in order to access it. So you might have a button that says second, and if you click that and then click sine, that sine -1 will come up. And you can type a value in there. So often it's the same button, but a second function. And if you look just above that button, you can see in tinier font what that second function is. So it's the same idea, it's just an inverse version of this ratio. So in this example, given the decimal value for each trig ratio, solve for theta to 1 decimal place. So we have that sine theta equals 0.6358, but we want to know what theta is. So it's kind of like the opposite type of question that we just did. We know what it's equal to, but we want to know what theta has to be in order for this to be true. So to isolate for theta, you bring the trig ratio, sine, to the other side of the equation, but that's when it has this -1. It becomes an inverse function when you bring it to the other side. So then you'll have sine -1 of whatever value is on this side, and you can put that into your calculator. So you click second function, sine, 0.6358, close your bracket, and you should get approximately 39.5 because we're rounding to 1 decimal place. It's important to include your units of degrees because that's what we're finding. We're finding theta, we're finding an angle. It's 39.5 degrees. And the same is true for cos and tan. You bring the trig ratio to the other side, which makes it an inverse. You type this into your calculator and round to 1 decimal place. So what we've just found is that in a right triangle, if the ratio of opposite side over hypotenuse is this, then that angle has to be 39.5. What we also found with the other ratios is in this right triangle, if the ratio of adjacent side divided by hypotenuse is this, then that angle has to be 50.5. So this is just the very beginning of trig, but you can see how we might be able to solve a lot of information about triangles using these trig ratios. Just a quick note that sometimes trig ratios will give you an error on the calculator. There's very few times where this is correct. So for example, tan of 90 degrees will give you undefined. It'll give you an error on the calculator. But most of the time, if you're getting an error, you may have just done something wrong. So it's a good idea to check that you haven't made a mistake or like you haven't forgotten a bracket in your calculator. So sometimes it's correct, and sometimes you may have just made a mistake. So what were our goals from this lesson? You should be understanding that sine, cos, and tan represent ratios of triangle side lengths. You need to understand that we use trig ratios to calculate missing angles or missing side lengths of right triangles. And you should familiarize yourself with using trig ratios on your calculator, including inverse ratios. So in the second part of this 8.1 lesson, we'll learn how to actually solve for missing angles and side lengths given different triangles.